In this video, we're going to be discussing power. So in power, you need to know that kinetic energy is equal to 1/2 of the mass times the velocity squared, and you need to know that potential energy is equal to the mass times the gravity times the height. So let's start off with question 1. We're going to write whether the kinetic or the potential energy is had of an object. So you serve a 2.1 kilogram ball at 10 meters per second. The ball has an amount of energy, and we want to calculate this amount of energy. So we know that we were given the mass is equal to 2.1 kilograms, and we know that the velocity was equal to 10 meters per second. We know that the ball is moving. And when it's in motion, we consider that to be kinetic. So we simply use the formula for kinetic energy, 1/2 mv squared, and we substitute in. Then we get 110 joules. This is just rounding error. So this is approximately 110, we're going to say. A cinder block is sitting on a platform 20 meters high. It weighs 79 newtons. The block has a blank amount of energy. Calculate it. So we know that the weight of the ball, the weight is going to be equal to 79 newtons. So, and remember, weight is different from the mass because weight is equal to the mass times gravity. So this accounts for the force of gravity that is already acting on the ball. And your gravitational G is always going to be different depending on what planet you're on. So on Earth, it's just 9.8. So we know that because it's elevated, when something is elevated, you can consider it to have potential energy. So then you know that your potential energy is going to equal to your weight times your height. And here we know that that is 79 and 20. So that's going to be 1,580 joules, approximately 1,600. There is a bell weighing 190 newtons at the top of a tower that is 45 meters high. It falls 20 meters. How much did the energy change? So we know that the weight is 190 newtons. Your change in height that it fell is, we're going to consider it to negative 20 meters because it fell from a state of higher to lower. So we're going to consider that to be a negative change. Now we want the potential energy change. That is going to equal to the weight times your delta H. A car is traveling with a velocity of 40 meters per second. The car goes up a hill and its max height up the hill is a blank. Calculate it. So we know that this is its velocity. And we know that at the top, your velocity becomes equal to 0. So that means all your kinetic energy has converted into potential energy. So you can say, and it mentions nothing about friction, so we don't have to worry about that. Therefore, we can just set them equal to each other, 1/2. You can cancel M. Is equal to 9.8 h squared. So you're going to have 800. So your height is going to be equal to 81.6, which is approximately 82 meters. A baby carriage is moving at 3 meters per second at the top of a 5-meter tall hill. The carriage has a blank amount of energy. What speed would it be moving at the bottom of the hill? So we know that at the top, V top is going to be equal to 3 meters per second. And we know the height is going to be equal to 5 meters. So we know that at the top, it has both kinetic and it has potential energy at the top. So that means we can write that using conservation, it still has to have kinetic energy at the top because it is continuing to move. So in order for it to move and then continue going down the other side of the hill, it has to have a little bit of kinetic energy left over. So you can write kinetic energy initial plus potential energy initial is equal to kinetic energy final. Because by the time it is moving down the hill, it's eventually going to come to a point of stop. And that means that all of your potential energy, because it's no longer on an elevated surface, it has no leftover energy in its potential form. So it's all going to be purely kinetic energy. So it's 1/2 mv squared plus mgh times 5 is equal to 1/2 mvf squared. So here we could cancel out the mass, which is why we didn't include the mass in our equation. So this is going to be 53.5. And that's approximately going to be 10 meters per second. A roller coaster is on a 70-meter long hypotenuse and has a 30-degree incline from a hill, and it weighs 1,000 newtons. The coaster at this moment has a blank amount of energy. So we know that the incline length, the hypotenuse, incline length, 70 meters. Our theta is 30 degrees, and our weight is 1,000 newtons. If you want to draw that, it looks like this. So 30 degrees, that's going to be 70 meters. Now we want the coaster at this moment. So first we have to find what the height is. The height is going to be the opposite, and it's going to be the hypotenuse from this angle that we know, which is our theta. So in order to find the opposite side, which we're going to also consider to be our h, different from the hypotenuse, we're going to label this hype so we don't get confused. The trigonometric relationship that relates these two sides, that's going to be sine, because sine theta is equal to the opposite over the hypotenuse. So we're going to have to solve for h. So h is going to be equal to 70 sine 30 degrees. Sine 30 degrees is going to be approximately 0.5. So h is going to be equal to 70 times 0.5. That's going to be 35 m. Now for our potential energy we know is going to be weight times the height. And we know that's the weight we were given was 1,000. And we know the height that we just found was 35 meters. So the total potential energy is going to be 35,000 joules. Now, the roller coaster's frictional coefficient is 0.2. The frictional force is going to be blank, so it loses this much energy. And we want to calculate this amount of energy. So we know that the coefficient is going to be equal to 0.2. But first, before we are able to find the energy, we have to find what the normal force is. So we're going to find N. So we know N, this is going to be equal to the weight component that is perpendicular to the incline. So imagine on this incline, we have our box here. And then on this incline, we have a force that is going to be perpendicular to it. Fn is going to be this. And Fn is going to be equal to mg cosine of theta. This is also going to be equal to mg cosine of theta. And they cancel each other out. Because if you had your mg here, and then if you had that as your mg, you would have this as your theta. And then if you had that as your theta, you'd have this as your theta. And then if you had that as your theta, then you could also write your frictional forces. You're going to actually draw this one to be a little bit shorter because it is accelerating down. And we know that in the horizontal direction, that this force has to be pulling it down. So let's just call this FA. It's going to be pushing it down. So we're just focused on the perpendicular forces right now. It's going to be perpendicular. So N is going to be equal to W cosine of the angle, which is 30 degrees. And cosine of 30 degrees is going to be approximately, if you type this in your calculator, 0.866. The weight was 1,000. So you have 1,000 times 0.866. That's going to be equal to 866 newtons. Now we want our frictional force, FF. And that's going to be equal to mu times the normal force. That's going to be equal to 0.20 times 866. And that's going to equal to 173 newtons. But we're going to round that down to 170 newtons to stay consistent. Now we want to find the energy that is lost. To find the energy that is lost, you need to find the work done by friction. Work by friction. So we know the work is equal to the force times D. And we know that our frictional force here is going to be what our F is. So we're going to just multiply that by our displacement to find our work. This is going to be equal to 173 times 70. And that's going to be equal to 12,000 joules. Its energy at the bottom of the hill is blank, and this energy gives a speed at the end of the incline as blank, and we want to calculate it. So we know that our initial amount of energy that we had was equal to 35,000 joules, and we know that the energy loss, which is the same thing as our frictional force, the work done by friction, that was equal to 12,000 joules. So we want to find the remaining energy. That's going to be 35,000 minus 12,000 equal to 23,000 joules. So this all becomes kinetic energy. So now we want to find the mass from the weight. In order to find a mass, we know that weight is equal to mg. Weight was equal to 1,000. Mass is going to be times 9.8. So if you divide by both sides by 9.8, that's 102 kilograms. Now we can use kinetic energy. So for our first blank, we had 23,000 joules at the bottom of the hill. And for kinetic energy, we have 23,000 was the total amount of energy. And we know 1/2 times our mass, which we just found was 102 kilograms, v squared. So we're going to have 23,051 v squared. V squared is going to equal to 451, dividing both sides by 51. And the root of that, 451 v, this is going to equal to 21 meters per second. 21 meters per second speed at the bottom of the incline. What is the kinetic energy of a 75 kilogram person running at 2 meters per second? So, mass of this person is going to be 75 kilograms. The velocity of this person is going to be 2.0 meters per second. We know the kinetic energy is going to equal to 1/2 of 75 times 2 squared. That's going to equal to 37.5 times 4. That's going to be equal to 150 joules. Now, we need to convert into calories. So we know that 1 calorie, 1C, is going to be equal to 4,184 joules, as is given. So we just take our answer, which was in joules, 150 joules, and we can divide that by 4,184, which is going to be this, and then that's going to be 0.036 C. Two objects are lifted. One has a mass of 2 kilograms lifted at a speed of 4 meters per second. The other has a mass of 2 kilograms lifted at a speed of 2 meters per second. Which object had a larger kinetic energy while it was being lifted? And show your reasoning. So we know that kinetic energy is equal to 1/2 of mass times velocity squared. So for the 4 meter object, or sorry, for the mass that's traveling at 4 meters per second, kinetic energy is going to equal to 1/2 times 2 times 16 joules. Now for the 2 meters per second mass, kinetic energy is equal to so because 4 is going to be having a joule amount of 16, it has more kinetic energy. The object that's traveling at 4 meters per second has a larger kinetic energy. Which object has more potential energy after lifting a distance of 10 meters? Show your reasoning why. So, potential energy is equal to the mass times gravity times height. So your mass is equal to 2.0 and your height is equal to 10. So your potential energy is equal to 2 times 9.8 times 10, which is 196 joules. So they have an equal amount of energy because they have the same mass. Because potential energy, it only accounts for 2 is going to be, they're both going to have a mass of 2. And their height that they're lifted is going to be the same. And gravity is the same on Earth. So they have, this is kind of tricky, but they have the same potential energy. Even though you just disregard the fact that they were moving at different velocities earlier. Because now we're only looking at the mass of them. They have the same mass and they're both on Earth and they're lifted to the same height. So they have the same potential energy at the same height that they're lifted to.